Hello all. In this video we will learn about flood routing studies for a dam. Flood routing is important to know the behavior or change in water levels when the water passes through spillway during flood situations. That is when the spillway discharging capacity is less than the maximum value of incoming flood, then there is increase in water level in reservoir. To know the increase in water level, flood routing studies are needed. This can be done by manual calculations also. This software also helps us to complete this flood routing study. It is very simple to do in the software. By following sequence as per the modules or models we can easily complete this. We will see with the example here. Let us consider this example. Here we can see the dam section at a location. Dam bottom elevation is 0 meters. Dam top is given and also full reservoir level is also given. Gates are also indicated in this section. These gates are crest gates. For different types of spillways please refer to the videos given in this channel. The number of gates are 8 and their dimensions are given. 15 by 12 meter in size is one gate. Gate's crest, that is bottom of gate, is also included here. Discharge capacity varies with different type of spillways. Here this is OG type of spillway. The formula for calculating the discharge is given. These formulae are dependent on head, dimensions of gate and discharge coefficient. Using this formula, total discharge can be passed at full reservoir level is 10,098 cumex. However, the maximum incoming flood is 15,000 cumex. Here we can see spillway capacity is less than the incoming flood. There will be rise in water level in the reservoir. We will see whether the water level rise will be below the dam top or not. To do this exercise manually and also using this software, we need elevation area capacity data, inflow hydrograph data and spillway outflow data that is at different levels. What is the discharge passing through spillway? This can be worked out using the formula shown here. Now we will start working in software. Like many softwares, we have to create new file at our specified place in system and units. Once this is set up, click Create. After clicking Create we can see this interface. Here we can see different options. In this software we have to follow or create components such as basin model to pair data manager as per sequence shown here. We'll start with creation of basin first like this. Once we have created basin, we can see left side, created items. In this basin manger, we can see options like creation of sub-basin, reservoir, source and sink and so on. For our problem, we need source that represents catchment of flow to reservoir. Then we need reservoir and sink. Sink means downstream condition just to collect the water released from reservoir. Once these three are created we can see them in the left side portion under basin. Each component will be having further details to enter. We will have to give input or fill the values accordingly. These inputs are self-explanatory and are easy. For source we need to mention what is the downstream component and flow method, that is flow measurement. We have inflow hydrograph, we can select discharge gauge. Once these are selected, we can see the same reflected in the left side under basin components such as gauge data. Same for reservoir data, also we have to fill the data. Downstream is sink. We have to select method. Various methods are available. We have spillway discharging values, so we can select outflow curve. Storage methods are also there are options. Whatever we are selecting, the same functions or data we have to enter. We are selecting elevation storage discharge. So storage discharge and elevation storage functions will appear. Now we have to create meteorologic model. This is we are creating just to complete the sequence. When we model rainfall data, this is useful. We can see hydrograph. We are already given discharge data using gauge. We are not modeling rainfall. So all the options in this model can be set to none. Control specific manager is to give the duration of analysis. This is generally give equal to the discharge values we enter in the inflow data. Time interval we keep equal to the inflow data time interval. Now we create time series data. Under this we can create many different type of data, that is stage gauges and precipitation gauges and so on. For our problem we are using discharge data, so we will select that. Like explained already, whatever we are selecting or creating we can see them on the left side under their respective tabs. In the time series data, we can see discharge gauge. In that also we can see gauge data and the respective input fields. We can enter the data and also can see the graphs. The balance data remaining is paired data. We have created elevation storage discharge method. We have to create these under paired data. These are again similar. We have to create and enter the data and we can see the graphs. Graphs help us to identify any errors in data. OG spillway discharge capacity formula shown in the beginning was used for estimation of discharge corresponding to different storages corresponding to different elevations. Now we have to select the paired data under Reservoir tab, which will be appearing now as we have created them. The important aspect of flood routing studies is to select the initial condition. Here we are selecting full reservoir level as initial level. That is, flood is impinging at this level. This represents the critical case. Accordingly, we have to enter the data in discharge gauge for the discharge near or equal to the discharge capacity of spillway at full reservoir level condition. Once all the input values are filled, we have to create simulation run under Compute tab. Creating simulation run required adding all the created components such as basin, meteorologic, time series, and so on. Once this is created, we can compute. In the bottom space, we can see the log of analysis. We can see errors if any. Generally, linking of data should be checked so as to avoid errors. Here the linking of gauge under source was not done, so error came. Linking gauge under source and compute. In the Results tab, we can check the results. Results it gives for each component, that is reservoir, source, and sink. Each will be having detailed results. We check the reservoir results to see the maximum rise in water level and also peak discharge passing through spillway. Here we can see the peak elevation in reservoir, that is 257.5, that is 2.5 meters above full reservoir level. This is rise in water level during inflow flood. We can see the maximum peak discharge also, which is 13,608, which is less than inflow flood. Here we can see the graphs. Bottom graph shows flow. Blue dotted graph is incoming flood graph. Thick blue graph is outflow from spillway. We can see here the peak of inflow flood is attenuated, that is reduced. This causes rise in water level. This attenuation sometimes needed to protect the downstream areas when there is excessive inflow into reservoir. This way we can model and check the rise in water level and attenuation in flood peak. Thank you.